In this video, we're going to look at U substitution and definite integrals. And there are two different ways of handling the problem of finding a definite integral with U substitution. And I kind of want to introduce both of them just through an example. So my example is going to be the integral from 0 to 3 of x squared times e to the x cubed plus 5 dx. And what I want to notice is that if I did not have this definite integral, which is these endpoints, I would immediately see that this is a U substitution because we've got a composition here, and the inside function is x cubed plus 5, and the derivative of x cubed plus 5 involves that x squared. Now, one way of handling a U substitution inside of a definite integral is to simply do the U substitution as normal and get all the way back to the variable of integration in the original problem before you do the substitution. And that's what I'm going to do here. And the first step is I want to remind myself that these are going to be x values. And I'm simply going to do that by labeling it as x goes from 0 to 3. And I start out the same way I do with any U substitution. I'm going to let U be x cubed plus 5. du is going to be 3x squared dx. And I'm going to rewrite this integral by fixing it up with that 3 over 3. And I have the integral as x goes from 0 to 3 of let's see, what I've got is x squared e to the x cubed plus 5 dx, and now I'm going to do the standard circling of stuff. That 3, that x squared, and the dx form my du, and this chunk here is an e to the u. So once I use the U substitution, the new integral becomes 1/3 as x goes from 0 to 3 of e to the u du. And it is extremely important to understand that I want to make sure that I understand that x is the variable for these endpoints. I have to get back to x's before I'm allowed to use the fundamental theorem of calculus and plug these values in. So to keep going, this is an easy integral. We have 1/3 times e to the u evaluated between x goes from 0 to 3. And now, of course, this is particularly easy because all I have to do is I have to remember that u is just x cubed plus 5. So the next step in this particular problem is going to be that I'm looking at 1/3 times e to the x cubed plus 5, and I want that to go between x is equal to 0 and x is equal to 3. And now it's just a matter of plugging in the numbers and putting in the minus sign. So we have 1/3 times e to the 3 cubed plus 5, that's 27 plus 5, minus 1/3 times e to the 0 plus 5. And so our final answer is going to be 1/3 times e to the, 27 plus 5 is going to be 32, minus 1/3 times e to the 5th. And that is a number, and we can just leave the answer like that. The other method for doing a U substitution is to convert the whole integral into u's. So I want to introduce this as a second method. Method 2. Convert everything, including the endpoints, into the new variable of integration. So into the new variable of integration. So let's look at the exact same problem and see how it will work under this method. So we're going to start with the same integral, the integral between 0 and 3 of x squared e to the x cubed plus 5 dx. I start off exactly the same way. I say, let's let u be x cubed plus 5. Du then is 3x squared dx, and I do notice that I am going to have to fix the integral up, so I'm going to go ahead and tell myself that these are x values, and we've got x squared e to the x cubed plus 5 dx. But instead of starting to circle things right now, the next thing that I'm going to do is I'm going to look at this. X equals 0 is going to imply that u is equal to 0 cubed plus 5. In other words, u is equal to 5. And my upper endpoint, x is equal to 3, is going to imply that u is equal to 3 cubed plus 5. That's 27 plus 5, that's 32. And I'm going to use all of this information to rewrite my whole integral in terms of u's. So let's see how that's going to work. This 3 and that x squared and that dx go together to form the du. So in my new integral, I'm going to have 1/3 times an integral, I'm going to worry about the endpoints in just a minute, of e to the u du. Now what I want to do is I want to use the fact that when x is equal to 0, u is equal to 5. So I replace the lower endpoint with, from x is equal to 0, I replace that with u is equal to 5. And I replace the upper endpoint, x is equal to 3, with u is equal to 32. So my new integral is going from 5 to 32. Instead of x goes from 0 to 3, u goes from 5 to 32. And so at this point I have 1/3 e to the u as u goes from 5 to 32. And since this variable here agrees with that variable there, I can go ahead and do the substitution, and we get 1/3 times e to the 32 minus 1/3 times e to the 5th. Now, which way you want to do a definite integral that has a u substitution is completely up to you. It doesn't matter to me which of the two ways you choose to do them. I would suggest that you figure out which way makes more sense to you and simply do it that way. On problems on the videotapes, I will probably switch it up and sometimes do it in the first way, and I will sometimes do it in this second way.